This Lunch and Learn is about Rust web development and why you should or can choose like a Rust stack for your next web service or part of your next web service. And my name is Bastian. I'm currently a solutions architect for a company called Atwilio. They're headquartered in San Francisco, and they do they are a communications API platform. So if you get a Zoom email, this comes from Twilio. If you get an Uber text message, this comes from Twilio. So they are sort of like the backbone for text and email and voice. I'm currently writing the book Rust Web Development with Manning. It's currently in MEP status, which means this is not yet done. The first 3 chapters are out, and the planned date is like around January, February 2021 to have the book done and then in print sort of by starting like March, April next year. That's the plan. And let's see if I can make it. And in my previous life, why I started this journey was I got interested in the Rust programming language. I started the Rust Intel Berlin meetup group 2 years ago now, I think, or almost 3 years ago. I was part of the back then async working group in Rust, where async await was not really implemented yet in the language. And I also worked as a Rust developer at a company called Kraken. It's like a digital currency exchange. You might have bought your Bitcoin over Kraken in the past. First about the book, and it's not too much about the book, but in case you're getting curious over the course of this talk, there are like many books about Rust out there, but not so many about the web development and not so many about actually a practical hands-on how you would use Rust in a production service as like a web service in your architecture. So like this book is meant for a person who has maybe 2, 3, 6 month experience with Rust and wants to join your team, or and they have a great like background in other programming languages, but you want to really hire them, but they have no prior really hands-on Rust experience. So the idea is you can hand them over this book and they can read the book from front to back, and then they are able to work in your team. If you look into like Rust as a programmer, also obviously feel free to grab this book, and it's like very hands-on, and after reading this book you can build a project. I also started to create a website for the book where I aim to publish more shorter hands-on articles where you can see like what you can do with Rust in a web environment. And this is the Rust webdevelopment.com. So this talk is structured in 6 parts. We will go through, because it's important to know like the Rust for web development could also mean why would you choose Rust in the first place. And to be honest, that Rust is probably the major reason why you want to use it for the web development part, because like Rust is so great that you might not want to miss out on this chance. I will go into the detail a bit why you would choose Rust, and then the second part of the book of the talk goes into how does Rust look like in a web environment, what comes like with Rust, and if we have time later on, we can go through some code examples, and so that you can get a feel about the whole flow. And why you would choose Rust? Rust comes with a very the language is strictly typed. So you have a very rich type system. We won't go into all of the details here, But this is the major starting reason why Rust is attractive for people coming from Go, from JavaScript, from Python, from Ruby, from Java. I worked with Rust developers and they came from C++ to Java to from all other languages, and they were just amazed by the type system and the options you have with Rust. So this is a basic example. It goes in much more detail, like which we can go at the end of the talk. Let me quickly admit this person to the screen. So you can create your own objects in Rust. As you see here, it's called a struct. You also have built-in types called, or like strings and numbers and Boolean and all the stuff you know from other languages. And this is how it would look like if you would implement your own type in Rust, and you can see that you can give an attribute to an object can be like another self-created type, as with name and address. You also have no undefined in Rust. So if you come from a scripting language, you might know that undefined is not a number or something from JavaScript. In Rust, it's not possible. And there are a thing called enums, as you might know from other languages, and the option enum is built into the standard library, and you can express that an attribute or a value might be there or it might not be there. And so, for example, we might have an age for the user, but we also might not, and we might have an address, but we might not, but we definitely need a name. And later on in your code, you can even check if there is an age or not. So whenever you come across a part of code where where the attribute is optional, the Rust compiler is forcing you to check if this has a value. So this is sort of like a long way of checking it. There's also some shortcuts in the standard library. I'm not sure why I didn't put this on the slide, but you can basically say user.age.has something or is number or is true, so that you don't need this whole thing. But this gives you a sense of how it looks like to dismantle an option in Rust. So the part where like Rust becomes interesting also for more than Ruby and Java people is that like Rust is a systems programming language, which means it compiles to a single binary and it has no runtime and no active garbage collection, which means it sort of feels like as unsafe as C or C++, because if there's no garbage collection, you by hand have to free up the memory you are using. But Rust and the Rust compiler makes it easy-ish by introducing a concept called ownership. In Rust, you either copy one value to a new variable, or you pass over the ownership. And you have simple types and complex types. If this would be like a number, and we can go through the Rust playground later, if you would assign this number here, also let's first go through like the string example. I will create like a new name here, and then I try to reassign this name to a new name, and then I want to print out onto the console this name. And the Rust compiler tells me that's not possible. And the reason is that a string is a complex type. It lives on the heap and not on the stack. And a complex types, like what happens if you, so now if this would be like a copy of the pointer here, so that like the name can hold this Bastian on the heap, and then and the variable new name can hold it on the heap. what if the value on the heap is removed? How do you notify both of the variables that Bastian is now not on the heap? So that you sort of have to start to think about synchronizing these two variables. And like Rust is circumventing this problem with giving a unique ownership to this value. So if I assign this name to name, then the variable name holds the ownership over the value on the heap. If I reassign it to new name, name is dropping this ownership, and now the new name has this ownership. And the compiler sees now that name has no more value for our program since it's empty now, like it doesn't hold any relationship to a data. It drops name of the map, like it doesn't exist here. That's the reason why I can't print out name, because name is transferring this ownership to new name here. And then the compiler makes it easy to tell you what happens. And here, like it says, here is a move from name to new name. You can, obviously, you have two scenarios where you want to have 2 or 3 things having the value in them, and you can copy it, which makes it a bit more expensive, so that you can have a copy, and Rust does this by default if this is a number, and numbers live mostly on the stack, which means it's cheap to copy. So if this is like a number, there is no move, there would be like a copy, and then you could print out name since name still has like a value. This is probably like another long talk about this concept, but it just shows you how this problem is solved by not having a garbage collection, but also being a systems programming language, and by making it easy for the developer to not to run into problems where they try to access like a value which is not there, which would be like in C, like a null pointer or something like this. And this maybe looks super complex, but in medium-sized application, it's fine. In more complex applications, it can get a bit tricky, but you can always steal yourself out of this conversation by just copying the value. It's also good to know that Rust compiles to a single binary, which makes it a bit easier in a DevOps environment to move this artifact through different environments. You would probably obviously build the different environments, or like in your CI/CD pipeline this binary. But if you start a Rust program, you start a single binary, which is good to know. And we go to the cargo part later, but it's obviously built in, and you can build a binary and ship it. With all this being a functional like a systems programming language with all these different concepts, it's also good to know that Rust at the same time looks mostly like JavaScript or Python for like 80% with a few types, which makes it easy to use, and you don't have to use like an object-oriented style of programming. You can mix both, and Rust is neither. You can write sort of functional. As we see here, we have an array, which in Rust is called like a vector. We can iterate through this. We can use map to increase the value, and then we collect the items. So this would then be, and the collect is doing, I didn't even test this, like the collect is collecting the values again, and I think here is summarizing it. And we can test this later on. And like a more hands-on approach in your application is if you have, for example, part of your code or like your model is a user account, and you can call these functions like this, and you can use the response from the previous one in your next one, and just calling the function on the response. So this makes Rust a fast systems programming language, which prevents you from problems like C and gives you the features from Python and Ruby and all the higher programming languages, which seems like that you can have your cake and eat it too, which is quite astounding. And I think that's the reason why Rust now 5 years in a row is like the most favorite programming language on Stack Overflow. When it comes to more of like the comfort features in Rust, this is a long example. This is taken out of the Rust book, that the documentation is built in. So you have doc style comments with 3 slashes, and you have normal comments with just 2. And if you annotate your code with the 3, you have a cargo build documentation, and in the end you will create like a website which you can serve, which has your code documented. It will already have compiled each of the structs, the implementations and the functions to navigate through, and in each of these sections will be your code comments here. You can even have code in your comments, and if you write test code, this code will also be tested, so that no code snippets in your documentations can be outdated. And here, this is more like Rust code. If you don't know, feel free to do a tutorial. But this is quite nice, since I know from the past in each of the projects, you have to choose a documentation style, you need to choose a library, you need to do all sorts of things. Then there comes a new lead developer and they are choosing a completely new tool, and then you have to rewrite half of the stuff, and Rust removes this baggage and comes with a documentation built in. The testing is also built in. You can have test modules and you can annotate the code. You have small little, these are called like macros, where you can write tests. So you have like a minimal set of test functionalities, and you can write just normal like Rust code, call your functions, import them here in this test module, and then see like what you can get out of it, so that you don't, like, again, if you come from JavaScript, for example, you don't have to go through all those 10 different testing frameworks. There's no need. Also, the linter is not built in, but there's something built close to the core of Rust, is part of the Rust GitHub repository organization, and it's maintained close to the core, which means you have linting built in. For example, if you have a variable which is not used in the rest of the code, the linter will tell you, hey, there is like a value which you don't use. You might want to remove it or prefix it with an underscore. This is in Rust world. If you don't need a variable, just prefix it with an underscore. And this linter is called Clippy. You also have the package manager included. You can create new projects, build the projects, run the projects, run the linter, and run the tests, all with the package manager. And you also have like NPM for JavaScript has, and I use JavaScript as the example, since I think all of us probably touched JavaScript at some point. It has now currently 63,000 crates are the packages called, and NPM has 1.3 million. So there's a discrepancy, but also know that the Rust people come from a prior language, so they might need less pre-built packages. And maybe like it still tells a story that obviously JavaScript is like 100 times bigger than Rust, but like Rust has a solid foundation of everything you might need. If you want to add a package, you have a cargo.toml file in your root of your source code, and you can add the packages here. And when you do like a cargo build or a cargo run, it fetches the code from the crates.io registry and installs them. You can also have local packages by just simply telling the path, and this handle package is part of the root directory of the source code, so you can just reference it here and it will get picked up. We talked briefly about the compiler, and this might be the biggest change in how you work and for your mental state of mind. If you're used to quickly debug in your scripting language, or if you're used to Java, where you maybe run some local test and you bootstrap a server, you run through some tests and you see, oh, this doesn't work. With Rust, you code against the compiler for probably 90% of your time until it finally runs. This might seem frustrating, but you get used to it, and afterwards you feel really naked if you code in like another language, because because like it's first hard to know that you can't like wing it, like you can't quickly write a few lines of code and see if it works. The compiler makes sure that everything, or 99% of your code, is bug-free, which makes it frustrating. But after like a while, you know that after you pass the check from the compiler, you feel safe. If you write a JavaScript code afterwards, or Java or Go, and it just like runs after the first try, you think, I'm not so sure about this, and you get a bit afraid. So you mostly work against the compiler, which is good to know, like when you start. So for example, we saw that we can match on an option if a user has an age, and let's say we forget the none part of the match. So that we match for some, but we forgot, or we didn't write like the none part, and we try to run the program, then the compiler will tell us, hey, there's something wrong. And it doesn't do so in a scary way. It actually tells us the line of code and the thing we have like forgotten. And here the compiler tells us, hey, there's something which you didn't cover. This also works with enums. If you have a self-created enum, let's say the calendar month, so from January to December, and you have a part of the code where you check, is this user born in July, and you don't check all the rest, then the compiler says, hey, you forgot January, February, March, and April, and so forth. You can trick it by doing just an underscore and say, please check for July, and in all the other cases, just do a default, but you have to cover these cases. And this makes it super, super helpful, even in your custom code, that a compiler makes sure that you don't forget something, and you also handle each of the failure cases. So good advice is to become friends with the compiler fast, because it's a good friend in the long run, and you will dearly miss the compiler if you would switch back to Go or to Java or to JavaScript. Now the question is, we figured out that Rust is pretty cool. It's a solid language, but why should I use it to write like web applications? Because maybe I'm used to Go, I know the quirks, it's fine, it runs like well enough. And it goes back first again to Rust by itself. After you have written Rust like for a few months, it feels like cheating, because the compiler tells you half of the stuff you have to do. Like the pattern matching, it tells you if you should use like a reference or not, if you don't need to copy the value here, but you can just put like a reference here. Rust tells you like a lot, and it teaches you to become a better programmer and have to think about your application, which means your applications increase in quality, which means they are easier to maintain. Also, after you have a stack in your company in Rust, it's easier to onboard new people because you know they go through the compiler, they have a quality code base there, and so forth. So this alone makes a good point to use Rust in your stack. You also have an ecosystem from people where it's obvious that Rust is not their first programming language, which makes the packages you use much better and have a much higher, like a much higher quality. And you have like a variety, I think 3-4 different major web frameworks in Rust, like which you can choose from, and based on your taste, you find something for you there. Also in a web environment, if you get a request and you type your or like you have types in your route handlers, it's already a failure case covered, because let's say that you have a REST API and you want to update a username, and in your route handler you specify that you like expect an incoming person struct. Your route handler will fail, and you can cover this case, but you don't. So many things are actively covered by a strictly typed language. In like addition, you also have the converting from your structs to or from like a JSON or a BSON type structure by a famous library called Serde. So with just annotating your struct with this here and adding like a small little library, you can now just respond a JSON and pass in a new person, and Rust will know how to format this to a JSON. If you get a person, you can just grab this person out, because the compiler knows how to form this person object from this JSON object. So this makes it super easy to use to work with JSON and your like Rust objects. And to a bit more of like a technical term, or like for like a long-term plan for your company, Discord switched, I think, yeah, like not all of this stack, but part of this stack from Go to Rust. And I think this was a famous blog post. And you can see here, based on the graphs, where in those peak times or like in peak requests, that the CPU in the Go code, like it spiked, and the Rust stays fairly stable. It also has like much better response times. And so like just by switching from Go to Rust, and Go is already a pretty fast and good language, it already like improved the performance of the application. You also have, and if you work with JavaScript and all the rest, and this is from like Microsoft, who are also betting a lot on Rust in the future. They say that like around 70% of the Microsoft vulnerabilities could be solved, or like that they were part of like the memory safety, and like Rust would solve these, or like most of these by default. This also means for your web application, you might run into the same problems, or you definitely will. And if you scale your applications, you will run into some form of problems here, where like Rust is good by default to not to have these in an easy way said. And it's obviously, this is from like Mozilla, who took over the Rust programming language project for an like immediate part of time. So it's, as we said, like it takes the burden off the programmer to write safe and correct code, which is a huge help, and which also is part of the web stack. You might think, I'm getting away with JavaScript, or my Go code is fine. I, as a consultant in the past 4 years, I joined companies for 6 months to help them out. I saw Go code and JavaScript code. They were good people, but it's just really, really hard to scale and maintain large applications in these languages. And Go, it's a great language. I like Go, but I've seen also like Rust in production, and this just outshines the rest for me. So all this being said, Rust actually doesn't come with a lot to write web applications. Since it's a systems programming language, it doesn't want to be too big, because it should also be used on like microcontrollers. So the standard library should be fairly small, which means there's no HTTP support in the Rust standard library. It covers everything from TCP, and it might not be needed, since if you, for example, run a gRPC like microservice architecture, you might not want to use HTTP. You might still do, but you also might want to use your own protocols. So you need to be like aware that you can use TCP from the standard library, but for all the rest, you need an implementation from the community. Check the time. So this means if you write a high-level web application, as you would do with Node, that's not a problem, since here are 4 web framework examples, and they all cover the rest of the stack. They ship with a server. They ship with all you need to do web applications in Rust, with a little caveat, and we come to that later. But if you just want to have like an HTTP server, you can, for example, use Hyper, and then you can create your own like route handlers and all the rest. And to write web applications, you might want to use asynchronous, like an asynchronous program paradigm, where you have, for example, in Node or Go with Go routines, where you don't want to handle all the threads on a kernel level, but you want to maybe have your own like event loop running on top of the kernel to be a bit more proficient. If they're coming like 1,000 requests like a minute, you don't want to offload this work maybe to the kernel directly. In Rust comes with a type and a syntax to do this. So in JavaScript, this would be a promise. In Go, I'm not sure what this would be in Go now. Go routines, I think. And you have the syntax also in the standard library, so that you can write code as it would be an asynchronous code. But under the hood, you have in Node.js the Google V8 engine, and in Go, you have the Go like runtime. In Rust, you need also some help from the community, and the most famous one is Tokyo, which I think also Discord is using, and all the companies I've seen are using Tokyo at the moment. And you have async STD, and you have more of them, and you can always build your own like runtime. And on top of this, and you have the kernel abstractions, which is also part of Tokyo, so that you don't have to know these, but it's good to know that this runtime sits on top of a kernel, but it needs to talk to the asynchronous kernel functions. And mu is covering this for you. And how this looks like in code, this is with like Warp, which is the example web framework, and we see here that's Warp. And we need to include Tokyo, the runtime, but then we write basic like Rust. So this is like a fully functioning HTTP like web server in Rust with Warp. It's a few lines of code and it works. And if you don't like the syntax of Warp, you can always use Actix or Tide or Rocket. And how to get them started. So after you know that you need these things, you want to get started. And in my experience, it's best to just to start to get your hands dirty. Just try to scratch an itch, create a little web service where you maybe fetch the scores from the European Cup or from your favorite GitHub directory. Just build something around a product you might want to use and have it in Rust, or try to rewrite a web service you built in the past, like a small one, and write it in Rust, and try to deploy it and see and add new functions over time and see of how it feels like to work with Rust. This is probably the best advice before you read books. Maybe even spend a week or like a month to try to build something and get used to, and I forgot this in the slides, get used to reading the documentations of your libraries. In other languages, you might use Stack Overflow. In Rust, there are not many answers there, and you will find all your answers at the documentations. As I said, the documentations is built in, so it's quite a high standard. And then if you want to use Rust in your team, so you've seen this talk and you've read my book and you want to bring your Go people or your Go team, hey, can we start to use Rust in our stack? Try to build a tiny microservice which you could rewrite in a week and create it in Rust. Because if it fails, you take a week and you do it like again in Go or Java. But try like a small one and try to write it in Rust and deploy it and monitor it, and then show the people, hey, see how the performance is. This was my experience with Rust, and then see if Rust can grow from there. You might need help, since if you're the only one doing Rust in your team or for yourself, you might need help to understand what is going on. And again, don't go to Stack Overflow so much. There are two different Discords. You probably want the community Discord for Rust, where they have channels for async, for beginners questions, for CLI, for game development, for all sorts of things. And you can go there and ask a few questions. There's also the Rust programming language Discord, which is more close to the Rust core, where they talk about working groups and all sorts of things. So it's not so much to get help there. It's more about keeping up to date with the core of the language. And you most likely, you might not, but you most likely will use Tokyo or the Tokyo stack in some form. They also have a tracing library. They have Varbis on top of Tokyo, the runtime itself. They also have a Discord with super fast help. I had a few questions in the past and they answered always nice and fast. Then if you decide that Rust is something for you, there is the official sort of the Rust programming language book. You can buy this from the No Starch Press, but you can also read it for free in the browser. And you can obviously buy my book, which guides you through all these steps of how to do, what to do, and explains the mindsets behind it. On the website I created for the book, I try to write short little blog posts in the future as well. And also check out your local meetup groups. I'm in Berlin, so there's the Rust and Tell and there's the Hack and Learn. But there's a Rust meetup group in every city, and now with being everything remote, the chances are high that if you want to join a San Francisco Rust group, they might meet in person again, I'm not sure, but maybe in Austria or in some place, they might still have it via Zoom. So it's a great chance just to log into Zoom and check them out.